Welcome to your future. Welcome to Vision Academy. Let us unlock your full potential.
If you've ever stared at a messy quadratic equation and didn't know where to start, there is a reliable method to solve it perfectly every time. To get the most out of this, grab a pen and a piece of paper. We are going to work through this process together. We'll start with a straightforward example, work through 3 harder variations to catch common errors, and finish with a challenge question for you to solve on your own. This is the standard form of a quadratic equation. The numbers attached to the x squared, x, and constant terms are our a, b, and c variables. Now, write down the Sridhar Achaya formula. Notice how its variables correspond exactly to the standard equation. Once you know how to extract those 3 numbers and plug them into this layout, you can find the roots for any quadratic equation. Step 1 is extraction. Let's look at our first equation. X squared plus x minus 12 equals 0. By lining it up directly beneath our standard form, we can identify our variables. Our a is 1, our b is 1, and our c is negative 12. Step 2 is substitution. We take those exact values and plug them directly into their matching slots in the formula template. Step 3 is simplify. We calculate the math inside the square root first, which becomes 1 plus 48, giving us 49. Then we multiply the denominator, 2 times 1, to get 2. Step 4 is the split. Because of the plus or minus symbol, our single equation now divides into 2 distinct paths. One path uses the plus sign, and the other uses the minus sign. On the left, negative 1 plus 7 is 6, divided by 2 gives us 3. On the right, negative 1 minus 7 is negative 8, divided by 2 gives us negative 4. Extract, substitute, simplify, and split. This sequence stays the same for every problem we'll look at. Let's apply that sequence to our next equation, where we face a common source of errors, dropping a negative sign during extraction. Here, our b value is strictly negative 7. When we move to the substitution step, we have to be careful at the very front of the formula. The formula requires a negative b,
subscribe,
which creates
and share
a double
our
negative,
video.
minus 7. As we push through the simplification step, that double negative resolves to a positive 7. Inside the root, negative 7 squared is 49, minus 4 times 2 times 6, which is 48. This leaves us with a square root of 1. We reach the split. 7 plus 1 over 4 gives us 2. 7 minus 1 over 4 gives us 6 over 4, which reduces to 3 over 2. Keeping strict track of your negative signs ensures you reach the correct roots every time. Now we look at an equation with a square root sitting right in the b position, negative 4 root 2. We follow our sequence, pushing through extraction and substitution. The result is a fraction that contains multiple square roots. To prevent mistakes, we can take this complex term over to a scratch pad. When we square negative 4 root 2, we square the negative 4 to get 16, and square the root 2 to get 2. 16 times 2 gives us a clean 32. We take that 32 back to our main formula, swapping out the messy term. The math inside our square root is now 32 minus 24. That gives us the square root of 8, which simplifies to 2 root 2. We hit the split. The plus path gives us 3 root 2, and the minus path gives us root 2. Even equations with complex terms are manageable when you isolate the individual calculations and solve them one small step at a time. Let's run through one final example quickly. We extract our variables from 2x squared plus x minus 1 and immediately substitute them into the formula. We push straight into simplification. The discriminant inside the root becomes 1 plus 8, which is 9. The denominator is 4. We split the equation. Negative 1 plus 3 over 4 equals 1/2. Negative 1 minus 3 over 4 equals negative 1. By following this exact sequence, you can process these problems quickly and accurately. Look at the grid. We started with a basic equation, addressed the negative sign trap, handled a complex root, and finished with a high-speed example. Here is your final quadratic equation to solve. Pause the video right now. Use the 4 steps: extract, substitute, simplify, and split to solve this on your paper and post your final values for x in the comments below. If this breakdown clarified the Sridhar Achaya method for you, leave a like and subscribe to the channel. You have the formula and the sequence. You can now identify the roots for any quadratic equation you encounter.
Like this video? Subscribe to our channel. Share this video. Thank you. Shukriya.